Finding angle measures given two parallel lines cut by a transversal. So first, two parallel lines are cut by a transversal as shown. So parallel lines means that they're two lines that never intersect, but they're always the same distance apart. So that's what makes them parallel. Kind of like the sides of the road. I'm not talking about the freeway or anything, just a basic road. So if the sides of the road started to come together, that'd be a little funky, because then eventually we couldn't drive on it. And if they kept getting farther and farther apart, that'd be weird also, only because it would get too wide. So the sides of the road generally stay the same distance apart. Again, just talking about a regular road, not freeways or turning lanes or anything like that, just the regular part of the road. And then a transversal is like this line here that's coming from top to bottom. So it's crossing both of the lines. So to transverse actually means to walk across or to cross over. So we're transversing the other two lines. We're crossing over them. So when this happens, when you have two parallel lines and a transversal, you get a whole bunch of relationships that come with it. So the first one that they have down here is corresponding angles. And corresponding angles are congruent. And I'm going to draw my figure like this. Here are my two parallel lines. Here's my transversal like this. And you know what? I'm going to leave the numbers off for now, just so that we can put marks in here. So I'm going to go back to my blue for a moment, so I can mark the corresponding angles. So corresponding angles, they are congruent. They are in the same position. So they are angles in the same position. And what I mean by that is if I grab this one that's on the top, so it's on the top of this first parallel line, and it's to the left of the transversal. Well, if I go to the other parallel line, and I'm on top of it, and I'm to the left of the transversal, then this is a corresponding angle because it's in the same position on both parallel lines. So by position, basically I mean the same position on the parallel lines. And so with that one, and so with that one too, it almost looks like you can take one and slide it right down into the other one. So I can do the same thing if I look at this side. So this kind of bigger angle on the other side here, I'm going to put two arcs so you know that it's not the same as these two. So I'm looking at a different angle. But if I slide down, I can go to this one, like this. So they're both on top of the parallel lines, and now they're to the right side of it. And it looks like I can take this parallel line here, or sorry, this angle, and if I could lift it up, I could slide it right down and it would fit right on top of this one. So that's the idea of a corresponding angle. Let's see. We also have supplementary angles, which we've already dealt with a little bit here. So supplementary angles add up to 180 degrees. So they add up to 180 degrees. And we also call these linear pairs, which means that they're on a line together. So if I identify any one of these lines and two angles that's on the line, then it's a linear pair which add up to 180 degrees. There's also, sorry, I want to make sure I'm writing all the notes here. So we're going to take up a lot of room here writing some notes. We also have vertical angles, And vertical angles and supplementary angles are not specific to parallel lines. Corresponding angles need parallel lines in order to be congruent. So vertical angles are congruent, and they're across the vertex from each other. So they're across the vertex from each other like this. So that means this angle is congruent to this angle. And I can also do that if I go this way. I can go like this. So this angle is also congruent to this angle because they are vertical angles. So the parallel lines aren't required. It's just two lines crossing each other. All right. And for now, it looks like those are the only three that they're introducing to you here. So we'll see on the next page if they actually expect you to have a few more of those. So let's see what we get. All right, so two parallel lines are cut by a transversal as shown. Angle 5, so this angle right here is 57 degrees. So let's see. Oops, that's not what I wanted to do. Just make this. Oh, that is definitely not what I wanted to do. So I'm just trying to unrotate this just a little bit because it was crooked. And how do I? No. All right. I just want to. Okay. So I'm going to go ahead and leave that alone just so I'm not messing with it too much. So if I'll draw this in kind of a bright green so we know this is part of the problem here. So my transversal going to my two parallel lines. So 1, 2, 5, 6, 7, 8, 3, and 4. I have got arrows on with these angles also. So they're telling us that this angle here, I'm gonna write it over here, is 57 degrees. So we know this angle 5 is 57 degrees. And they want us to find angle 2 and angle 3. So they do expect you to know a bit more about angles than what they gave you on that last page. Because that last page was not quite enough from what they gave us. So in order to get from 5 to 3 here, I would have to know alternate interior angles. So I'm going to put alt instead of alternate, just to save a little space here. So we have alternate interior angles. So I'm really shorthanding that just again to save some room here. And they are congruent. And the way we identify alternate interior angles is this is interior. So interior means inside the parallel lines. So in between my hands is inside and my hands are the parallel lines. And the point or the angle needs to be inside my hands. And then alternate means that they're on different sides of the transversal. So the transversal is going through and one is on the left side, one is on the right side. And in this case, the transversal is going sideways, so we could say one is on top and one is on the bottom, something like that. So that's all it means, is it's just telling you exactly how to find them. So in this case, I'm going to use this dark gray here. So if I have angle 5 here, I'm on the inside of the angle. And then if I jump to the other side of the transversal here, because I'm on top of the transversal, if I go to the bottom, I'm still inside the angle, and I'm just on the other side here. So these are called alternate interior angles. 3 and 5 are alternate. So in this case, I know that 3 is also equal to the 57. And that's just because of the definition of alternate interior angles, which oddly enough they did not give you on the last page. So now we can use the supplementary angles that add up to 180, which are also linear pairs. Because if we look at these two, 3 and 2 are on the same line. So I know they have to add up to 180 degrees. And I already know that 3 is 57. So I'm going to subtract here. And I get 127. Sorry, 123. We get 123. So if you notice, because 3 and 5 are congruent, this actually opens up another condition for parallel lines. Sorry, lost my wording there for a minute. So 3 and 5 are congruent because they're alternate interior angles. And 3 and 2 have to add up to 180, which also means that 5 and 2 have to add up to 180. And this is actually another one of the conditions that parallel lines meet. So consecutive interior angles, we can write this up here. So I'm not going to be able to write consecutive. All right, interior angles add up to 180. So that's also another thing. So if they're interior and they're one right after the other, so like 2 and 5 or 3 and 8, they have to add up to 180 degrees. All right. So I'm going to make this much smaller. So we're going to end up running out of room if they get, oops, they give us too many more of these theorems and postulates about parallel lines. We're going to have a lot of room to write math out here. All right. So this, especially once we get to the parallel lines and transversals, there are a lot of notes. So I do encourage you to take the notes and keep them for next time, because quite a few of these topics will have these same notes. So it'll be convenient to not have to write them down so many times, or if you can just add to them as we build and go through here. All right, so this is 2 parallel lines are cut by transversal as shown. Angle 6 is, so, oops, forgot to change it to my pen. So that did not look right. Still doesn't quite look great here. So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, gotta learn to write a little tinier on here. All right, and it tells us that this angle here, angle 6, is 67 degrees. And they want us to find angle 1 and angle 2. So this one, they did give us the tools to find this one. So if we come over here, I'm going to select my green because this is the color that I actually wrote this rule in. So I'm actually looking at corresponding angles here. So if I'm looking at angle 6, it's on top of the parallel line and it's on the right side of the transversal. So if I go to the other parallel line, I slide right up. I'm on top of the parallel line and I'm to the right of the transversal. So I know that this angle 2 that I just drew this arc on also has to be 76 degrees. Didn't quite draw that pointing at the right place there. There we go, 76 degrees. And that's convenient to know because once I find that angle 2 is 76 degrees, I can use vertical angles, which they also gave me on that front page, which I wrote in red here. So I can go across the vertical angles, and I know angle 4 then also has to be 76 degrees. So this is very much so about kind of bouncing around the rules, not around the rules, but going from one to the next and knowing how to move forward. So it's a lot of trial and error too. I saw right away the corresponding angles. You might not. You might have to bounce around here a little bit to figure out where to go. So now, once I have either 4 or 2, I can use my supplementary rule. So I'm going to come down here and grab blue. So I'm going to draw a line here. So I have a line, and 2 and 1 are on the same line. So I know they have to add up to 180 degrees. And I know that 2 is 76 degrees. So I can subtract and get 4, 0, 1. So I know that angle 1 has to be 104 degrees. All right. So we didn't get any new rules on that one. Next. With dark gray again here. I'm going to just draw. It's just a little bit easier if I can draw on it and see exactly what it is I need to find. Six, 5, 7, 8. There we go. Okay. So, and then they tell us that angle 3 is at 136 degrees. Oof, that was a really ugly looking 136. 136. There we go. So this angle 3 here is 136 degrees, so it's a pretty big angle. Theirs looks a little bit more accurate than mine, definitely. Mine does not look like a 136 degree angle, but that's all right. And then they want us to find angle 6 and angle 7. So we actually have all the tools we need to go ahead and find these. So one of the ones that we found on that first one that I actually had you write, or I wrote in darker gray here, was consecutive interior angles add up to 180. So if we look at 3 and 6, they're consecutive interior. The reason is because they're both inside the parallel lines, and they're one right after the other. So they don't skip anywhere. They're both just right inside parallel lines, and the consecutive interior angles also have to be on the same side. So they both have to be on the right side or left side. So I've also heard these called same side interior angles. For whatever reason, it depends on which book you're in. So same side interior angles does make a little bit more sense description-wise. Consecutive just means one right after the other. Just like if you were counting consecutively, you go 1, 2, 3, 4, 5. So one right after the other. All right, so I know 3 and 6 have to add up to 180. And I know 3 is 136. So I'm going to subtract. And I'm going to get 4. Oops, forgot to borrow. Borrowing in my head there. And then we get 4 again. So I get 44 for angle 6. So I know that. Not 644, sorry. Angle 6 is 44. And then now I need to find 7. So I can either subtract from 180 again because these are also on a line, or I can use this consecutive angles rule up here. So I'm going to come over here and grab my blue. Just like to have them color-coded a little bit. So if I'm looking at angle 3 here, didn't change to blue. Why didn't I change? There we go, changing to blue. So I'm changing that to blue. And I'm on the bottom of the parallel, and I'm to the right side of the parallel. Then I'm going to slide down to the other parallel. I'm going to go to the bottom, and I'm going to stay to the right side of the transversal. So again, I'm just going from top to bottom. I'm just kind of sliding right down. That's called corresponding angles. Corresponding angles are congruent. So if angle 3 is 136 degrees, angle 7 is also 100. Oh, darn it. I'm finding angle 7. We wanted angle 8. See, silly me. Finding the wrong angle here. So I'm actually making you do the wrong rule. What we want, since we already know 6 is 44, well, we can just go like this and go straight across right here like this. Because these are vertical angles. Anytime you have lines crossed like this, you have a vertex that you can cross over. So if angle 6 is 44, then angle 8 is also 44. So both my answers are 44 on this one. All right, so we're done. Yay!